Hi students, hope you are in the good condition. So in this topic, you will be learn about the pharmacy calculation tree. Under this topic, there will be 4 learning objectives. The first one, you will be learn about the dilution and stock solutions. So you will be use one or two formula and to identify or determine the next of the the concentration using the vial, and how to determine the final drug concentrations after the dilution. Second learning objective about the allocations. So there will be two type of the allocation that you will be learn further, which is the allocation method and allocation alternates. So in this allocation method, you must understand the purpose of the allocation method, and you can use the allocation method to solve the problems. And you also can use another allocation method, which is allocation medial, to determine the relative amount of the component that needs to be mixed to make a required strength of a mixture. The third one, I will be learn about a simple density, and the next simple formula, which is the specific gravity. So under the first learning objective, which is the dilution and stock solution, you will be learn on how to solve the problem involving the dilution and concentrations of the liquids and more further. But before that, you need to understand some of the knowledge about the diluent. So basically, diluent is a substance that added to a pharmaceutical product, whether to reduce its strength or you want to dilute the strength. So a diluent most often has no drug substance in it, in which diluent usually like vehicles or water and have no active ingredients, for example, such as sterile water and petrol ether. So basically, by looking at this figure, this is the pharmaceutical preparations before the dilutions. Okay, so basically, as you can see, this is the active ingredients in the orange circle, and the diluent or water in the blue color. So when you add some more of the diluent, okay, so you are adding the vehicles but not adding the active ingredients. So basically, after the dilution, the active drugs or active API, active pharmaceutical ingredients, is still the same, but the volume of the mixture has been doubled. Stock solutions, it can be expressed as either in the percentage strength or in the ratio strength. So basically, stock solution can be imagined as a concentrated solution before any of the diluent or water vehicles being added into the solution. And in this first learning objective, the very important formula, which have the Q1 or C1, Q1 multiply with the C1 equal to the Q2 multiply with the C2, or you can using the C1 V1 and C2 V2. So if you have the information about the quantity, volume, or concentration, you can use the Q1C1. And if you have the information about the concentration and volume, then you can use this C1V1 formula. So yeah, let's take an example. This is one of the example that can be used to utilize the Q1 C1 and Q2 C2 formula. For example, before the concentration being dilute, it have 15% of the concentration strength, and the volume of the mixture is 500 ml. However, if it's being diluted with additional of 1500 ml of the water, so they want to know the percentage strength of the next mixture. So by using the Q1C1 equal to the Q2C2, you can have the answer of 5%. You can either use the Q1C1 equal to the Q2C2 formula, or you can use the inverse proportion. So this is a second example. So do you still remember that I've been informed that stock solution, it can be expressed as either in the percentage strength, as in the first example, or in the ratio strength, as in this example. So in this example, it's stated that if 50 ml of a 1 to the ratio of 20 weight of a volume solution are being diluted with 1000 ml of the diluent, for example, what is the ratio strength of the next concentrations? So basically, if the concentration or percentage strength in the ratio, then you can convert them into the percentage strength. So 1 to the ratio of the 20 equal to the 5%. Okay, so by using the same formula, Q1C1 equal to the Q2 C2, so you can have the nets of the concentration strength equal to the 0.25%, or if you want to convert in the ratio form, it's equal to the 1 to the ratio of 400. In the first learning objective, there will be few of the calculation that you need to know. The first one, the previous one, is the dilution and concentrations of the liquids. So in B, you need to determine the amount of solutions of a desired strength. For example, in this question, it's stated that how much the 10% weight over weight in the gram ammonia solution can be made from 1,800 gram of 28% of the strong ammonia solutions. So as I've mentioned before, in this first learning objective, just remember about the Q1C1 equal to Q2C2 formula. So by using the same formula and by placing the information in the correct places, so you got the answer equal to 5,040 gram of the ammonia solution. Okay, in the Q2 concentration. This is the same example by using the same formula. However, the information being provided in the ratio form. So in any of the concentration strength that have been provided in the ratio form, you can convert into the percentage strength form. And by using the Q1 C1 formula again, you got the answer as equal to 1,250 ml. So in this third subsection under the first learning objective, they want you to identify the amount of the solution needed to prepare the desired solutions. So in this subsection, they want you to determine the amount of the Q1 or C1 of the solution lah. Okay, so basically in this question, both information being provided in the ratio form. So in this question, you need first to convert all the ratio form into the percentage concentration form, and then by placing the Q2 and C2 and with the concentration strength in the C1, then you got the answer X or Q1 quantity of the solution needed to prepare the 0.05% of the 4 liter equal to the 800 ml. So students, this is the fourth subsection under the first learning objective, which is they will give the information about stock vial or ampules. So in this questions, the first one, you can convert the 5 mg ml and 65 mg ml into the percentage strength, and then you are using the Q1 C1 and Q2 C2 formula, and then you placing the concentrations. This is the concentrations, and 30 ml is the desired concentrations. So how much of the stock solution that will be required with the 6.5% of the solution to make a 30 ml with a 0.5% of the concentration strength. Or you can use the first solutions. The first solutions is for you to understand. So the first one, they want you to prepare the ml from the 5 mg over 1 ml. So 30 ml from 5 mg per 1 ml equal to 150 mg. However, the next statement informed you that phenobulb from the manufacturer have the 60 mg per ml. So in 150 mg of the phenobulb, okay, how much of the ml from this 150 mg? So by using the information in the second statement, you got the volume of the phenobarbital equal to the 2.3 ml, which is equal to when you are using the Q1 C1 and Q2 C2 formula. This is the fifth subsection under the first learning objective, which is the question want you to determine the quantity of the active ingredient in a specific amount of solution given the strength of the diluted portions. So the question asks you how much of the silver nitrate should be used to prepare 50 ml of the solutions such that 5 ml diluted to the 500 ml will yield or produce a 1 to the ratio of 1000 solutions. So you have the 50 ml of the diluted portion, okay, and you want to identify how much of the silver nitrate should be used to prepare this one, such that 50 ml of solutions, 5 ml being diluted to the 500 ml and yield to the 1 to the power of 1 to the ratio of 1000. Okay, so basically 1 to the ratio of the thousands equal to 1 gram of the silver nitrate in 1000 ml of the solutions. However, you want to identify how much of the how much gram of the silver nitrate in the 500 ml of the solutions. So in the 500 ml of the solutions, you have 0.5 gram of the silver nitrate. However, the amount of the silver nitrate in the 500 ml is equal to the 5 ml. Okay, so basically, since the 50 ml and the 5 ml are the same strength, you can use the inverse proportion and you got the amount of the silver nitrate used in the first of the quantity or the Q1 equal to the 5 gram. Come to the sixth subsection under the first learning objective, which is the question want you to identify the amount of the diluent needed to prepare the solutions of a specific lower strength. So this question asks you how much water in the milliliter should be added to the 300 ml of a percentage strength in 1 to the ratio of 750 weight over volume solutions of the benzyl chromium chloride to make nuts mixture with a strength of 1 to the ratio of 2500 weight over volume solutions. Okay, so before you want to proceed, you need to convert all the ratio in their percentage form. So the 1 to the ratio of 750 equal to 0.133% and 1 to the ratio of 2500 equal to 0.04%. Still, by using the Q1 C1 equal to the Q2 C2 formula, you just are putting the amount of the 300 ml with the relative strength which is 0.133% after it's been converted in the percentage form, and then the X, which is the one that you want to identify the water that should be added to this mixture with the percentage strength of 0.04%. So you got the 997.5 and you round to the 1000 ml. Okay, so basically this is the 1000 ml. However, you already have the 300 ml. So the next step is you need to subtract the final volume with the Q1 volume to identify the amount of the water that should be added to the 300 ml to make the nuts mixture 0.04% of the 1000 ml. Okay, students, so this is the last subsection under the first learning objective, which is the question want you to identify the final drug concentrations after the solutions. In this example, it stated that if 25 ml of a 0.06% atropine diluted with 10 ml of the normal saline, what will be the final drug concentrations? So basically, you still can use the Q1C1 equal to the Q2C2 formula. However, it will be easier if you first identify the amount of the 25 ml from the 0.06%. So the amount of the ipratropium bromide from the 25 ml of 0.06% equal to the 0.015 gram. It's stated in the question that 25 ml is being diluted with the 10 ml. So 25 ml, you first need to be add with the 10 ml equal to the 35 ml. So by using the next step, which is the amount of the 0.015 gram over 35 ml times 100 equal to the 0.043%. So basically, this is the final drug concentrations after 25 ml of the atrovine with 0.06% being added with 10 ml of the 10 ml of the diluent, and the final drug concentration, the quantity of the API in the nuts mixture being reduced from 0.06% to 0.043%, since more of the vehicles being added in this mixture.